All right, so welcome to our video on level 1, the properties of a square and their application. Now, the first thing we want to look for when we're working with a problem that is a quadrilateral is make sure it is a square. You'll notice here it is explicitly written that ABCD is a square. So that is very, very important information. When we're working through these, that might be something we might want to annotate. Square. Because when we know it is a square, we know it has all of the properties of a square. Which, if you're unsure of those properties, please check out my video on the properties of a square and the definition of a square. So, I've given us two pieces of information. I said that AB is 7 2/10. I'm writing that down here. I've also said that BK is 5 1/10. 5 1/10. So, I'm going to switch this to our black so we can start to work in some of these answers. Now, let's start with the side lengths first. You'll notice here I've asked for the length of 4 different sides, or 4 different pieces. AC, CD, AD, and KC. Now, let's look at AC first. You'll notice AC is one of the sides of a square. And as most of you know, if you've watched my videos on the properties of squares, all of the sides are the same. Many people know this already. All the sides are the same. So in fact, all of the sides are going to be 7 2/10. All right? So we have AC, 7.2. I have CD, that's 7.2. And again, this comes from the fact that this is a square. Oh, sorry. And do that for us. Now, because it's a square, again, we know that all of the sides are the same. I mean, that's going to be very helpful for a lot of the different problems we're looking at here. Now, next thing we're asked to look at, because it's a square, really also because it's a rhombus. I'll write that in there too. Remember, rhombuses have all congruent sides, so a square is a rhombus. Now let's look at AD. Now we could figure out what AD is, but I think it's helpful to find possibly what KC is first. We know BK is given as this length here, and because we have a parallelogram, that means that the diagonals bisect one another. So these two lengths have to be the same. In any parallelogram, that will be the case. Same thing over here. These two lengths will also be the same. Again, that's a property of a parallelogram. So KC is also going to be 5 1/10. Again, we know because this is a square and a parallelogram that the diagonals bisect one another. This comes really more from a parallelogram. Now AD. AD is a little bit tricky. Notice they didn't give us any lengths on this side. But if I know what BC is, I didn't ask for BC, but I know that BC, since this is also 5.1, just like we labeled, is going to be 10.2, or 10 2/10. If I know that BC is 10 2/10, if you look in our properties of a square, AD will also be the same. Since a square is also a rectangle, the diagonals are congruent. So you can see how the square applies all of the properties we've looked at so far. Again, square, rhombus, rectangle, and parallelogram. A square fits underneath of all these categories, so it shares all those properties. All right, now let's check out some of the angles. Now I asked for a lot of angles here. I asked for a ton of angles. So I'm going to try and get some of our annotations off of this so we have a little bit more space to work on. I'm going to leave those angle numbers in there. All right, so we have our angles 1, 2, 3, 4, and 5. Back to where we were. Now, You'll notice for this problem, I didn't give us any of the angle information. I did not give us the measure of any angles. But since we know this is a square, many of the angles are given to us. In fact, all of our interior angles are 90 degrees. That's one of the definitions of a square. If you're unsure of that, please check my video on the definition and properties of a square. It's the one I just posted before this one. So all of these angles are 90. Angle A, B, C, and D all equal 90. In fact, this is what makes a square a rectangle. They need to have all 90 degrees. Where things get a little bit more difficult is when I ask for some of these portions of the angles. Because for angle 1, notice that's not all of angle A, it's just a piece of angle A. But if we look at some of the properties of a square, we know that the diagonals bisect each angle. So if A is 90 degrees, all we do is we split it in half. 45, 45. So angle 1 is just going to be that 45. We just take 90 and divide it by 2, split it into 2 equal pieces. In fact, all of the diagonals are going to do this. Because all of the angles are 90, all of the bisected angles will be split into 45, 45. So it's pretty easy to follow that angle 2 is also going to be 45 as I've labeled it. Angle 5 is going to be 45 as I've labeled it, 45 degrees. So we're just left with angle 3 and angle 4. Now there's a few different ways we can look at this. We could look at some of the properties of a parallelogram, or properties of a square, or we could use our triangle sum theorem. Notice we have a triangle here. I'm going to try and trace this in a little bit thicker of an ink. Between here we have a triangle. And we know that there are certain properties that are true about triangles. In fact, that the total interior angle measure, blank plus blank plus blank, must equal 180 degrees. Total interior angle measure of a triangle. So we know one of them is 45. We know two of them is 45. We're just trying to figure out what angle 3 is. So I'm going to call that question mark. So we combine our two. 45 plus 45 is 90. Plus question mark equals 180. Subtract 90 from both sides. And we get question mark equals 90. So our angle 3 is going to be 90 degrees. Which shouldn't be surprising as well, because if we remember back to our special right triangles, 45, 45, 90 is one of those types of triangles. Very, very helpful to know. So that's if you forget the properties of a square. Now, there's an easier way of doing this. In fact, I'm going to erase all this nonsense out of the way. We don't even need all this information. If I'm looking at angle, let me relabel angle 3 and angle 4. Here's angle 3 and angle 4. If you check your properties of a square, you'll see that each of these angles formed by the diagonals are all going to be 90 degrees. That's one of our properties. If you remember that, you don't even need to find the angle using the triangle sum theorem. You should just know that from the properties. All those interior, all the angles formed by the intersection of the diagonals are going to be 90 degrees. So this is a really, really helpful video on how we can apply all the properties of a square, dealing with lengths and also dealing with angles. So make sure you've copied down this example thoroughly. If you have questions, leave me a comment. I'll try to do my best to get back to it. Leave me a message on BCPS1. Send me an email. I would also advise you guys, if you have trouble setting this up, check out my video on the properties, because if you don't know the properties, it will be impossible to answer these questions. Well, thank you guys for taking the 10 minutes to watch this video. Make sure you like and subscribe to my channel. Comment, again, if you have questions or you think any way I can make this video better. Also check out my other videos on special quadrilaterals. Thank you.